Hey Dr. Lane, so I'm doing a reassessment for the standard we had that was chapters 1 through 5, and what I messed up on the standard, that's kind of what the concept I'm focusing on because we only have 5 minutes to do these, otherwise I've done another problem. But the problem I picked was there's a box of mass 45 kilograms that hangs motionless from 2 ropes as shown in the diagram above. The angle alpha is 36 degrees. Choose the box as a system. The x-axis runs to the right, the y-axis runs up, and the z-axis is out of the page. So they asked us to pick a free diagram from what I had, and I drew what it looked like. Well, here's first of all what it looks like. The rope 1, rope 2. Here's the angle that it forms. That would be alpha, which is 36 degrees. This should be kilograms, but anyway, so there's a force pulling on it this way, which would be rope 1. Rope 2 is pulling at it at an angle connected to the top here, and the force of gravity is pulling down on it. And the first question asks, what is the y component of the gravitational force acting on the block? So the gravitational force is mass times gravity, so that's the only thing pulling it in the y direction. So you multiply negative 9.8 meters per second squared, so you get negative 441 newtons. Now, the second one asks, what is the y component of the force acting on the block due to rope 2? So it's this rope. Now, even though this rope is acting on it at an angle, and it would be in both x and y, it would have x and y components, this one's only asking for the y. So if gravity is pulling on it with a negative force, it would have the same force, only positive in the y direction, it would be positive. It wouldn't be negative like it would be up here because it's holding it motionless. So they would just cancel each other out. The next question asks, what is the magnitude of the force to like this rope? And for that, you would use the force. Wait, where am I at? Yeah. You would use the force divided by cosine of alpha. And the reason you use cosine of alpha is because, well, we're trying to find this total magnitude of the force right there. And we know this force right here. That's why we would use cosine adjacent over hypotenuse. And you'd rearrange it and you would plug in your angle, and from that, when you plug in everything, you would get 545 newtons. The next question asks, what is the x component of the force on the block due to rope 2? So from that, you would pretty much use this force that you just found and multiply it by cosine of 90 degrees plus alpha. That's because you're using all of this angles right here plus this. It's the same concept, really, but you're looking for the x component, which, I mean, it says of rope 2 because you're using the force, but really it's going to be of the rope 1 because that's the only thing acting on it in the x direction. Only it's pulling it this way. That's why we would put a negative, because otherwise you would get a negative answer. And when you plug everything in, that's what I did here, you get 320.3 newtons. That would be in the in the x direction of rope 2. Now, kind of jumped ahead explaining that one, but the last question asks, what is the x component of the force on the block due to rope 1? Well, that answer would be the same answer we just found in the previous question, only it would be negative because, once again, like I said, that's the only force acting on it in the x direction, only it's pulling it like in this way, so that would be negative. And you can just see from the diagram, that's the only thing acting on it right there, x direction. That's a combination of both, but we figured that out using the magnitude. So that's what I did. Thank you.